Hello and welcome everyone. My name is Mark Henry. I am a senior engineer with Opmantek's North American office located out of Charlotte, North Carolina. Today's webinar will be on creating a root cause and problem resolution workflow in your NOC. This is very much more of a change management or a process related workflow as opposed to a specific list of steps or guidance on how to use any network monitoring solution, not just Opmantek's piece. So you can actually reuse the content here for whatever solution you have in place in your workplace. Just as a reminder, for all of those of you who are joining us today live in the GoToWebinar, we will be sending you a follow-up email with a link to the recording of the webinar. Feel free to submit your questions anytime using the GoToWebinar questions panel, please. And upon completion of the webinar, or when you log out, if you have to leave early, you'll be presented with just three quick, simple questions. So if you could complete that exit poll, we'd appreciate it, as we use that information to help formulate future webinars. For those of you who are viewing this recording later, either on the Opmantek website or on our YouTube channel, you should also find an associated copy of the handout in a PDF format, so feel free to grab that as well. Today we're really going to focus in on three kind of straightforward concepts when it comes to root cause analysis. First, we're going to talk about the power and flexibility of root cause analysis, or RCA. We're also going to touch on kind of the operational and process changes that are needed, both mentally and physically, literally the things you need to do or the things you need to have to be able to support kind of a RCA mentality. And then we're going to touch on, just very lightly, the different troubleshooting features built into Opmantek's network monitoring solutions that can directly support root cause analysis. During our webinars, I really like to try to marry back each of the concepts that we're presenting back to Gartner's IT Service Management Maturity Model. So when it comes specifically to troubleshooting or root cause analysis specifically, you're really looking at helping to improve and solidify the concept of initiating a problem management process, right? How are you going to deal with each individual event? And then also event management itself, of course. That all help lends itself to more of a mature problem configuration, change, asset, and performance management process. That in itself leads you up to level 3, helping you shift to more of an IT as a service provider, right? So you're becoming more of a consulting organization or a consulting department within your business, as opposed just to a firefighter, a break-fix team. This, of course, helps you be able to guarantee the SLAs that you're providing. Again, that's irregardless of whether you're a managed service provider helping support a third-party organization, or whether you're an internal department providing support to other departments within the group. And finally, of course, this helps elevate you solidly into IT as a strategic business partner. Being able to proactively manage events and issues throughout both the network and the applications that are being monitored really makes you more of a strategic asset, again, than you would be strictly as kind of an ad hoc or a break-fix team. So some useful references for you. Again, because we're not necessarily focusing in on Opmantek's products, we won't be marrying this back to specific product lines. However, there is a blog entry I wrote in December of last year. The link is the first one on the screen here. And again, for those of you who are joining us live today, there's a copy of this handout or this presentation in a PDF format on the GoToWebinar handouts panel, so feel free to download that. And if you found us on YouTube or on the Opmantek Learn portal, you should be able to find a copy of both this presentation, and also that link will get you the blog entry, which is a kind of a primer in root cause analysis. So you should read that before you continue on and complete this presentation. Of course, if you have any questions at all, feel free to post them to the community questions board on our wiki. If you are a supported customer, you can send them to support@opmantek.com. So you'll get direct access to our engineering team. And if you have any questions over any of Opmantek's products, if you'd like to get pricing or like to schedule a demo, you can reach out to us at usa@opmantek.com. And if you're outside the North American area, then we'll be happy to give you an introduction to the sales team that handles your specific geographic location. So why should you start looking at RCA, at root cause analysis? At the end of the day, it all comes back to really trying to get the highest ROI over whatever network monitoring system you have in place. And again, this presentation is really NMS system agnostic in many ways. You can apply the types of concepts that we're going to be talking about today to any network monitoring solution that you might have in place, even if they're specifically manufacturer specific type solutions, or if you have point pieces that are out there, etc. But at the end of the day, it's about getting an ROI on your investment. And so if we consider implementing Opmantek's network monitoring solution at kind of an average enterprise class business, it's been our experience over the past 5 years that we've been kind of collecting data on our customers and the types of performance improvements that they see, that most enterprise class businesses we encounter on a weekly basis are generally operating at an SLA of about 97% uptime. And what that means is that at any given point in the year, if you look back over the last 12 months, they would have experienced about 262, almost 263 hours of system downtime per year. So when you start looking at Opmantek solutions and the different types of information we provide, how we help provide root cause analysis support, how we help you reduce your your time to problem resolution, how we help you increase your mean time between failures, how we help improve the quality and reliability of the network, what you end up seeing really is that we help reduce the downtime by an average of 68%. That means you go generally from 263 hours to 84 hours, which increases your SLA from 97 to 99%. And for that kind of average enterprise class business, which is doing about $150 million a year, that creates a savings in revenue and productivity of $2 million. And that's $2 million realized every single year that you're utilizing our product line. And right off the bat, if you just look at the cost of Opmantek solutions compared to that productivity, it creates an ROI of 93%, which means that investing in Opmantek solutions generally pays for itself in less than 10 months. So at least 2 months out of the year, you're actually making money on investing in Opmantek solutions, which is a huge turnaround, generally speaking, for most product lines. And of course, you can do this kind of analysis, again, on any network monitoring solution. So whatever solution you have in place, you should be looking at how it helps you be able to identify the root causes of the events happening across your network, how it helps you reduce the time to be able to get to that root cause, to implement a fix or a solution. And then you should also be looking at how it helps you improve operational capacity and reliability of your overall network, and understand what that does for you, because every tool that you purchase should be providing some kind of ROI to your team. So let's talk about root cause analysis specifically. Now, earlier I gave you the reference again to the December 2018 blog entry, a primer for root cause analysis. Again, please read that before you really try to implement RCA methodology. We won't be going in depth into RCA today in this presentation. This is, again, focused more on what are the pros and cons of root cause analysis, and then how do you help shift the mindset and implement it in an organization. Generally speaking, I'd say about 75 to 80% of the clients that we engage are really taking troubleshooting from more of a reactionary, or what you would call a firefighting standpoint. What that really means is that all of their network troubleshooting is really kind of ad hoc. There's no process, there's no kind of goal or thought behind it. All their response is reactionary. Every time a ticket comes in, a phone call comes in, or something pops up on the big board, they're taking it as an individual element or issue, and they're dealing with it. Whoever picks it up, whoever it gets assigned to, is dealing with that. But there's not really a process or procedure. Many businesses we talk to have no run book, so they have no documentation as far as what are the steps that should be taken for different types of events or events on different types of equipment or equipment that supports certain classes of customers, let's say external customers, VIP customers, customers with very stringent SLA requirements, which all means that overall the responses end up being undocumented. They're often uncoordinated. There's no process involved as far as what steps should an engineer take, not just to troubleshoot the process, but what should I do first? Do I notify someone? Do I call someone? Do I generate a help desk ticket? Do I update the website first? What should I do, and in what order, and who should I pick up the phone and call? And finally, of course, a lot of times we'll see that the ability to troubleshoot a problem can oftentimes be based more on individual experience and expertise. So engineers who are more senior, who have more experience in the network, more familiarity with the network architecture or specific types of equipment, will have more experience, more know-how, and so they'll be able to troubleshoot problems quickly. Whereas more junior engineers, or engineers who simply haven't attended certain classes on specific types of equipment or aren't familiar with those pieces of equipment, oftentimes approach troubleshooting problems on those types of devices from a more undisciplined approach. So, having things that are documented, having a process in place helps pull those all of those together. And of course, what ends up happening is when you're fighting a fire all the time, is that your troubleshooting results are unpredictable. So when you start looking at how long does it take to actually solve a problem, it's all over the board. It all depends on what engineer is doing the troubleshooting, what type of equipment, what type of problem, and of course that will happen always, regardless of what type of methodology or process you have in place. But when you do have a methodology in place, the swing of that unpredictableness, or the amount of time it takes to do root cause analysis and identify the actual core cause of a problem, shrinks. So what does implementing a root cause analysis framework really bring to you, right? So it helps reduce the probability of repeated behavior. When I worked on this list, I kind of banged around the idea on if this shouldn't be really the last bullet. But instead, I present this first because, from my mind, one of the things that we often encounter when we talk to prospects and customers is the fact that they'll tell us that an event, a major network outage event that cost them lots of money happened last month, and it just happened last week all over again. And so, when you start digging into those types of things, and they tell you, well, we fixed the problem then, but it cropped back up. So that tells me that they fixed maybe an ancillary issue, but not necessarily identify the root cause. And because if you don't identify the root cause of a problem, many times you'll have repeated behavior. You'll have that same issue come back again. One of the second benefits that you'll find really is that you'll be able to identify the root cause, really, again, and not just a symptom of the root cause, which is something that is quite frequent, especially in troubleshooting by very junior engineers or inexperienced engineers. The third benefit you'll really find from implementing a root cause analysis methodology is that you'll be able to implement a fix or corrective action for something. Many times you'll have engineers who work from the most recent issue, or rather from the oldest issue backwards to the more recent, rather than prioritizing issues that are customer impacting or that are more high cost issues. And as a result, those things cost the company more money. And if by the time they get to a really high cost or high impacting event, if that event has cleared itself for whatever reason, if they haven't collected any kind of troubleshooting information to help them with that event, then being able to implement a fix or a corrective action may escape them. So they've lost that opportunity, which means, of course, then you're back to the item number one, reduced probability of repeated behavior. Because if you can't gather enough information quickly and accurately, if you can't use that information to then really focus on determining a root cause, then you can't implement a fix or a corrective action. And of course, your probability of having repeat behaviors goes up. Fourth, by doing an RCA, or following RCA methodology, you're able to document the issue for other users. A challenging factor, again, is that kind of in-house knowledge or tribal knowledge tends to be held in the hands of a very small number of people in engineering teams. And being able to accurately document issues and what caused them and how those issues were troubleshot, what symptoms were seen, how those were looked for, being able to keep track of that information and make that information available to other users in ways that make sense is a huge benefit for them. It'll continue the more often you document issues, you'll see that information helps reduce the time for troubleshooting future events. And fifth, it allows you to adjust process to capture and address similar events faster. So if you see something happen, if you see that on Monday I'm missing apples, and why am I missing apples? Oh, this is why I'm missing apples. And then on Wednesday you're missing oranges. You have a similar issue, and then you can look back and say, well, we had an issue earlier and we documented it about apples. Maybe there's something similar there, or maybe we can learn from how we troubleshot the missing apples to figure out why we're missing oranges today. So what kind of power and flexibility is really granted from applying an RCA methodology? Of course, we covered the pieces a moment ago, but really it comes down to really helping every member of your engineering team become a productive member of the team. We often see very fragmented organizations that might be broken up into silos, server team versus networking team versus desktop team. Sometimes you'll have split outs as well, DevOps teams versus monitoring teams, NOC teams versus engineering teams, implementation teams. And so there ends up being walls between teams, very little communication. And again, that kind of tribal knowledge held in the hands of a very few number of people doesn't get documented well, doesn't get shared with other team members. And so implementing an RCA process can really help every engineer step up and become a productive member. The second issue, or the second piece we really see, is that the process itself is very, very flexible. So there are lots of different steps that can be included in the RCA methodology. I cover many of them in the blog entry I did in December, again, a primer for root cause analysis. But the concept here is that irregardless of the type of underlying equipment you have or measurement tools, and again, those are network monitoring solutions. Those could be point solutions provided by vendors. They could be specific solutions provided by third parties. It doesn't matter. But your process, your RCA process, is flexible enough that you can use any tools you can to help fill in the process. It's about looking at what you have, as opposed to saying, in order to implement this process, you must have these 3 pieces of software, and you have to spend this much money, and you have to hire high-cost enablers or consultants. And that's really also the third thing there, is that pretty much anyone can implement a root cause analysis methodology. I was working with a smaller regional WISP just the other day, and they literally have an engineering team of 3 people. That's it. They've got a couple thousand customers. They're a small office, and these 3 people are basically working 9 to 5 Monday through Friday, and then they're all on call after hours and on the weekend and on holidays. And one of the things they didn't want to have to do was go out and hire someone and spend $400, $500, $600 an hour for them to come in and tell them all the different software and books and things that they had to buy. They wanted to be able to take on and learn a process themselves and mold that process into how they do business and how their team works and how their team can work. And so looking at a root cause analysis, looking at the methodology and the different ways you can implement RCA at your organization, they're actually able to tackle it themselves on their own without having to go out and hire a third party at all. So once you've kind of looked over the concept of root cause analysis and the different methodologies and the different steps that are in the process, understand what the 5 whys are and how you would employ them, then once you decide, okay, this is the direction we want to go, we want to try to adopt as much of this as we can into our current workflow, modify what makes sense, and kind of move forward with this. So how do you do that? How do you actually apply those types of kind of theories and methodologies into your process? So right off the bat, it has to be supported by senior members of the engineering team, right? Just like any other change management process, it has to come from the top down. It doesn't necessarily have to be from the C level or the director level of your organization, but at least people like the NOC manager, the engineering manager, right? These people have to be on board. They have to not just buy into it. They can't just be telling you, yeah, go ahead and do some research and do what you can. They have to be behind it 100%, because if they're not behind it, then there isn't going to be as strong an adoption of the people who are actually going to be doing the work on a day-to-day basis. And of course, in most cases that we've dealt with anyway, at larger teams where you're looking at 10, 15, 20, 30 people, as part of the NOC team, as part of the management engineering structure, and of course, also as part of that kind of core group of information holders, right? If you don't have their support, it's going to be very, very difficult to implement the change in any kind of a reasonable amount of time and get everyone on board so that you can see positive results. So how do you get to where you want to be? Once you've decided on adopting root cause analysis as kind of your troubleshooting methodology, what you need to do is really start kind of a focus group or a core group of people. You need to get 2 or 3 at least together. I wouldn't really go more than 5 unless you have a really large NOC and engineering team, because if you get too large, if you get too many people involved, you'll never get decisions made. So I like to keep it small. I like to start with a core group of 2 to 3 people, make them process owners and mentors, right? You want to read through as much material on RCA as you can, and we have several different resources on the website listed with that blog entry as well. You want to then have that group define your process, right? So RCA has, depending on kind of the vertical market or the type of thing that is creating the errors, the events that need to be kind of troubleshot, there are different types of processes. So if you're working in marketing, there's actually a marketing RCA. If you're working in technology, there's a technology RCA. If you're working in software development, there's a software development RCA. And the processes are similar, but they're different enough that you really want to look over the different kind of step-by-step processes, pick the one that works best for your vertical market and your implementation, right? How your team works. Once you select your process, then you'll be selecting your tools. Now, a lot of people get lost in the idea of, oh, I've got to go buy this really expensive top-end Ishikawa fish diagramming tool, and there's all these things I've got to get. And no, you don't. Start with a piece of paper. Start with a whiteboard. Start with sticky notes, scratch pads, right? Start with something to get you going and get you started and get you moving forward. There are tons and tons of free or open source solutions that are out there. Everything from wiki tools like Confluence that can really help you do all of your notations, all of your wikis, all of your documentation, capturing information for your team, indexing, all of that stuff. There's tools out there like Atlassian's Jira that can really help you keep track of bugs and events and keep all of your kind of your troubleshooting notes in one spot. So there's lots of different tools that are out there. You don't necessarily have to buy ones that are specific to RCA, as long as they provide you with enough of the features to really support the process that you're developing for your team. One of the last things I would suggest is don't become paralyzed on tool selection, right? If it takes you more than an hour to pick a tool to help keep track of things, you're spending too much time on it. You can always upgrade later. You can always move forward. You can always port over to something else. And of course, if you start with paper-based, you can always move to electronic at some point. So once you've made those kinds of selections, you want to gather your resources, right? And I've said it a couple of times today already, but generally speaking, engineering knowledge tends to be held in the hands of a very small group of people. Generally, they're very senior engineers. There are system architects. They're software architects. They're DevOps managers. And you've got to start gathering that knowledge, capturing that information, and documenting it. And having a way to document it that is referenceable, is searchable, is fantastic. At the same time, I've seen NOC groups where the kind of the NOC manager, the shift manager, they just had a running log, and they'd take notes throughout their shift, and then they'd go over anything that was important with the manager that relieved them on the next schedule. And once a day or once a week, the NOC manager or the engineering manager would review the logbook just to see what notes had happened, what kind of events had occurred, and then see what things had to be passed on for further analysis. You want to make sure that whatever you're using for your documentation is indexed and searchable in some way, right? Again, whether that's a handwritten notebook that's passed down watch to watch, or whether that's an online system like Atlassian's Confluence. You want to be able to make it so that as you add notes and information to your documentation, that your junior engineers can find things intelligently. And last but not least, you want to make sure that everyone understands, from the management team on down, that this whole process is an ongoing effort. It's not a one and done type deal, right? This is something that over time it will grow, it will modify. You should be expected to nudge and push and move your process. Who does what, when they do it, how far they do it, how they document it, who they share that documentation with, how decisions are made, who can make what level of decisions. All those types of things should remain rather fluid, and especially rather fluid over the first 4, 6, 9 months that you implement the RCA methodologies. And the reason for that should be self-evident, but really, it's the concept about making small corrections consistently over time in order to reap large benefits, right? You don't want to throw the baby out with the bathwater. You just want to say, okay, how do we get the dirty bathwater out of the tub, right? Well, let's lift the baby up and then drain the tub. So, making small nudges works. Once you've got kind of the process laid out, once you understand what it is you're going to be doing, once you start doing your documentation, you get your documentation underway, so that you kind of start capturing that tribal knowledge, that knowledge that's held in the hands of a handful of really senior engineers, right, or architects. Then you want to start training that core group, that group of the 2 to 3 people. Again, maybe as many as 5, right? You want to start training them so that they are comfortable with the process. And the way you do that really is you pick an incident, right? You pick an event that's particularly troubling, and you walk through your RCA process. So you walk through your 5 whys. You try to keep asking yourself, why did this occur? How do I document why this occurred? What things can I look at? What software can I look at? What measurement tools can I look at? Which network monitoring solution or which NetFlow or IP fix tool will tell me what's happening? Where can I get the information I need to answer why this occurred? And then keep asking yourself why. And you want to continue to try that with several incidents over several days with that core team. The whole idea is that you're trying to prove to yourself how easy or difficult it is to apply this process with the tools that you have and the types of systems you have deployed, and also the types of issues that your team's dealing with. So as you're kind of working through this, the whole idea is to get the entire core team on board with understanding what the process does for them and how to work the process. Because you want that core team to be really, really comfortable doing this. Because you're not just going to use this core team as kind of like the demonstrators, right? But they're going to be the mentors. They're going to be the people who are working on shift with the NOC engineers, seeing events popping up on the big board, seeing events coming in via email or on the phone from people, and then working through those events with them and helping train the engineers hands-on, right? The people who are actually going to be sitting at the desk, working the problems day to day, shift to shift, and working with them. And so you want those mentors very, very familiar and very, very comfortable with the RCA process and methodology that you've settled on, and in using all of the tools, how to get to them, and making sure, of course, that they can then teach and demonstrate all of those processes and tools to everyone on their team. Finally, once your mentors or trainers are really trained, then the next step is to train the engineers. Now, some people will start with a classroom training exercise and then move on to shift supported training. Others will go strictly to shift supported training, more of an apprenticeship approach. Either way is fine. Whatever works for your organization and the type of mentors or trainers that you have and what you're capable of supporting internally. Again, this isn't kind of a hard and fast process. The whole point here is to be as flexible as possible with your team so that they can use the tools at hand to get the results that they're looking for. And finally, one of the big pieces here is that, again, this is a living process, right? So as tools and equipment evolve, as you roll out new devices into the out into your network, as you get them out and start using them and they start generating alarms and events and triggers and issues, you're going to have to nudge your process a bit. You're going to have to move things around. You're going to have to add additional documentation. You're going to have to make sure that the documentation is maintained and is kept up to date, and that it works and that it ties in with whatever network monitoring tools or documentation tools that you have. And so that way, as things work together and as they move and they progress over time, by taking this kind of an approach, generally speaking, what we've seen is that the time engineers spend trying to identify what a problem is, how to identify how to fix that problem, again, root cause analysis, and then implementing that fix, that whole time, or usually represented as mean time to resolution, right, MTR, that time will shrink. And what that means is that the engineers will have more time between events in order to continue to maintain the documentation, add better processes, better information behind the scenes, and also help continue to improve the overall reliability of the network. Because as you improve the reliability of the network, then downtime again shortens and shrinks. Mean time between failures, NTBF, increases, which is what you want, right? Because when you do good root cause analysis, when you find the root cause and you address the root cause, you reduce the number of recurring similar events. And you also help engineers be able to understand and say, oh, we saw something similar to this just last week on another router on this side of the network. And this is how we identified the problem, and this is how we fixed it. And now you have a kind of a footpath to problem resolution for the new problem that you have. So that all helps you improve that kind of quantitative repair. And again, as a living process, you don't want to throw out the baby with the bathwater. So you just continue nudging it. You continue moving it. And whether you change the underlying tools, if you swap out one NMS for a different one, if you acquire new equipment that has its own vendor-specific point solution to it that you want to implement or integrate into your process, just keep nudging it, right? As you get down the road, maybe that kind of core team of people might meet once a day, and then once every 2 or 3 days, and then once a week, and then once a month, or maybe once a fortnight, so once every 2 weeks. And then they'll come up with new diagrams and processes, and those might be printed out into workflows, or they might be put onto the wiki pages to help people internally really understand what are the things they should be doing, what are the steps they should be following. So before I switch over to Opmantek Solutions and just kind of give you a quick walkthrough of some of the different ways that we help support root cause analysis, if you have any questions on this topic, that's my direct email address. I do try to respond to everyone's email. That's also my direct cell phone number that's on there as well. I am on the East Coast U.S. time, and I generally work 8 to 5 Monday through Friday. If I can't take your call, please don't be angry with me. Just leave me a detailed message, your name, your number, and whatever kind of question you have, and I'll get back to you as quickly as I can. If you have any questions regarding sales or pricing inquiries, you can send those over to our account executive here in North America, Tom Wary. Tom can be reached at usa@opmantek.com. So taking a look, I'm going to touch on 3 different Opmantek products here over the next 10 minutes or so. I'm going to touch on Opie Charts, which is Opmantek's dashboarding tool. The concept here is to be able to create a single pane of glass that gives you a view into all of the devices and all of the applications that are across your network. So whether they're networking devices, routers, switches, hubs, firewalls, load balancers, whether they're hardware or software defined, whether they are Windows servers or Linux servers, Unix servers, ESXi servers, Sun Solaris, if they respond to SNMP, if they respond to WMI, or if you can pull information back from an API, if you can pull information back in JSON or WMI format, or query an SFTP site and pull performance data and then parse that out. Our solution can do it and keep track of information and then kind of tell you what's happening to devices. And so understanding what kind of information is available to you. So for example, if I wanted to drill into a switch, and let's just find one here. Got a couple out in the cloud. There we go. Let's take a look at B&E Lab RR1. So this is actually a software-defined device. This is a little Cisco router. It's running iOS. It's emulating a 7200. So you can see right away that I've got a nice breakdown in this tool. Now this happens to be Opmantek's NMIS, Network Monitoring Information System, is actually handling all of the pulling information from this device. It's creating a detailed topological map, so we're understanding all of the different subnets this device supports and devices that are on the end of that subnet. We're also breaking out lots of information here down the left-hand side, node status summary. So we're seeing all of the different warnings that we have. So several BGP peers are down. Proactive response time is high. There's an error there as well. So there are several different elements here that we could be drilling into and trying to understand. Are these elements that we need to be worried about? Are these elements that we could stop monitoring, that we should stop alerting on, or is this something where the configuration of this device needs to change? In kind of thinking through and looking at this degraded device, as far as it comes to kind of a root cause analysis and understanding why is this degraded, the NMS that you select, the network monitoring solution, is really going to drive what your steps are to RCA, right? So in this example, I can see here my status of my device immediately. I can see that certain BGP peers are down and that the response time on the device is very high. When it comes to things like response time, generally response time is driven by system load. And so I might want to look at things like overall reachability and availability. So I can see over the last 8 hours, I've had some ping loss, I've had some reachability issues. I can see these over here in my KPI indicators as well. I can also drill down into this device and looking at certain performance graphs. And so I'll want to look at things like response time of the device, CPU utilization. So I can see here, for example, over the last 8 hours rather, CPU utilization has come up, popped over a couple times over 35%. That's not bad at all. Number of routes to the device have bounced up and down between 126 and 127. IP utilization seems pretty good. And then coming down over on the left-hand side, I can actually break down into additional pieces that are here. So I might look at things like memory-free I/O, processor memory, used memory. So used memory on this guy is, there's been some spikes here. You can see there's been a lot of spikes over the last, again, few hours. And then look at the average busy for 1 minute, and average busy 5-minute times as well. So by taking a look at these things, these pieces, we're able to get a feel for what might be happening here. You can see again we've got some spikes over the last 8 hours. So that's average busy 1 minute. And then look at the CPU average busy 5-minute time. And again, we've got some spikes that are coming up here. Not tremendously high, but a little higher than normal. Tying in with these pieces, I've got the availability to drill into our IPAM solution, so I can look at address configuration for this device. I can see the node context as well, so I can understand what other pieces are involved here, and I can also pull into the events for this device. I can connect directly into our configuration compliance piece and see the node configurations on this as well. So there's lots of pieces that I connect directly into. Opmantek solutions, we kind of position them as almost like a dim sum menu or a tapas menu. You can pick and choose the solutions that make the most sense for you. So many of our clients start with, for example, Open Audit, which is our device discovery and auditing solution. They'll then add in NMIS, our network monitoring piece, which is the core of our performance and fault monitoring. If they want these high-end charts and graphs, they'll add in Opie Charts to that as well. And then from there, they might add in our event manager of managers, OP Events, which does event deduplication, correlation, and OP config, et cetera, et cetera. All of these all plug together. So as you add more and more solutions, these different buttons that are on the screen turn on and off, or show or don't. The whole idea being is that you get quick access to the information you need. And that's really a core piece when it comes to kind of fast problem resolution and troubleshooting, is having access to information at your fingertips. It's being able to go from a 50,000-foot view, whether that's a geographic display, a topological display, an overview of your network as a whole, and being able to drill in very quickly and say, oh, there's a problem in this geographic region, or in this chunk of the network, or in this application, and then go from that 50,000-foot view very quickly down to kind of a medium level group view, like a 10,000-foot view, where you're focusing in on that geographic area, or that network topology, or that group of elements that support that application, looking at those and then drilling from there further into an individual device and understanding, is this a service related type outage? Is this a process related outage? Is it a hardware issue? Are we overloading the device? What's happening here that's causing the problem that we're seeing? And having these other tools available to you, and being able to drill into those tools very, very quickly to capture more information. The faster you can get to information, the faster you can get to a resolution. So along those same lines, if you take the approach more from an event standpoint rather than from a process standpoint, but if you're more event driven, from our event module, there's lots of different ways to look at events. So you might look at events over time. We have a specific NOC view called current events that can be customized for priority. It allows you to do very, very fast applications. So for example, acknowledging events, keeping track of those events, and then also allows you to go very quickly from a very high level. So for example, I can go from the idea of service degraded. I can drill down. I can see how often this device has had an issue with disk read write times. I can also see the fact that we've gathered some additional troubleshooting information on this event. You can see we've done a Linux drive space here. We've captured some information. We've stored that information here. I can also change my event status. I'm investigating this event now, so we can keep track of this. And just like, pardon me, sorry, didn't mean to scroll on you. But just like in OP Charts, where we had a list of different types of applications here, we can do the same thing. We've got, we can acknowledge the event, we can add comments, we can look at the details of the event, the raw details of the event itself. We can view the node directly in NMIS. If this device, if this node has a contextual link, we can follow that link as well. We can again connect into OP address. We can look at the node performance, look at the node configurations. We can edit this node internally in OP events, and we can look at more events about this device. So we can actually drill further into the history of this. We do have some of that on the right-hand side over here. We have the last 2 hours of events for this device. This happens to be my demo server in Brisbane, Australia. But all the details are here as well under the details piece. So again, what information do you have? What information do you have available to you? And how does it come in? And of course, if you're looking at events caused by configuration changes, having some solution that can monitor your network for configuration changes, monitor all your devices, routers, switches, hubs, firewalls, regardless of manufacturer, model, or operating system. So this is very specific. It will actually log in using Telnet or SSH. It'll execute whatever CLI commands are appropriate for that specific device, and then it will back up the results of those CLI commands. And so, for example, if we continue looking at BNE Lab RR1, I can see there have been 766 changes over the last few hours, and you can see the several changes happen every day. You can see the different commands that have been executed and how many revisions there are. And for example, very quickly, I can go into show running config. I can compare the revisions of this command. I can run a visual diff just so I can see the revisions. And if I scroll down, you'll see on the left-hand side, there's an entry on this interface, IP OSPF cost 9999. So that makes this interface very, very costly to run traffic through. And that's redlined, that's outlined in red and lined out. And you'll notice in the new version of that interface configuration that the IP OSPF cost command is now gone. So someone has reconfigured the interface on this device and they've changed it. And of course, by changing the OSPF cost, they've either pushed traffic off this interface, or in this example, by removing the OSPF cost, they've actually allowed traffic onto this interface. So gathering information and having information available to you, having a system like Opie config be able to execute commands, gather configurations of devices, and then alert you on configuration changes, or in the case of Opie events, be able to push events back to the event management system and have the event management system run its own troubleshooting. So in this case, we've got this this event here, interface discard input packets that occurred. And in this case, the system's run a ping node. It audited the device using OpenAudit. And then it was automatically acknowledged due to a state change. So the issue changed. So lots of different things that can be done. Here's another one, interface error input packets. And in this example, our system actually ran a troubleshooting escalation, ran a couple of scripts, which actually created that entry for the OSPF cost 9999. So it actually rerouted traffic on that interface or off that interface. Then it ran an MTR fast, a ping node, and an audit of the device. So having solutions that can automatically gather troubleshooting information, obviously all of that helps add to root cause analysis. And again, it doesn't matter if you're using Opmantek solutions or some other set of products. This same process applies to all of them. The more that you can automate, the more information you can capture to lead for troubleshooting, all goes into the bucket and helps reduce the time to root cause analysis and identifying the problem and then resolving the problem. So I want to thank you all very much for your time today. It's been greatly appreciated. Again, my name is Mark Henry. I'm a senior engineer here with Opmantek's North American office in Charlotte, North Carolina. If you have any questions at all about root cause analysis or any of Opmantek's products, how we might be able to help you and your organization, please feel free to reach out to me at markh@opmantek.com. Thank you all very much for your time today, and I look forward to seeing you again at a future webinar.